It means that differences exist between each group. Anyone that gives you less than the LSD, which is also the critical range value, will say that there is no difference between those particular what pair that you've selected. Then you can go on and make your conclusion. This is all about one sample test for, one factor Weigh Anova test. And this is where we'll hold on in terms of the Anova. If you have any question, please ask me so I can pick another example quickly and solve it. Any question? No, I think Batilda, I'll give that example to you to solve, okay? So please remind me to send it to you, your email, so you can share to your friends. Is that okay? Batilda, are you there? Class rep.
Yes, sir. Doctor, please, I'm here.
Great, great, great. So let me just keep this. This is a question. I just picked a question. We want to test whether the mean time waiting in a queue to be served in the same is the same for all EcoBank branches in Accra. Okay, so the head office, can you see the question I'm reading?
Doctor, please, is it yes, we are now seeing it.
Okay, so we want to test whether the mean time waiting in a queue, that's the average time you spend waiting to be served, is the same for all EcoBank branches in Accra. So the head office provided the average time spent in 3 branches. This is the sample they gave. Based on this, we have the mean time at Legon branch, Silver Star Tower branch, and the ANC branch. Sorry, this one should go here. The ANC branch, okay? So if you have a data this way, we want to find out whether the average time spent in the queue to be served is the same for all the branches. And we said that based on this, because we have the 3 sample, we cannot use the 2 Z-test or T-test. So straight away, you have to use this data. The first says use this data to test whether, okay. I think I was using a different question. To test the mean time for all the branches, yeah. And I'm saying that you should use 0.05, then at 0.05, use the Fisher's LSD procedure to test for the equality of the means for branches 1 and 3. What conclusion can you draw after carrying this test? I hope you can solve this. So I'll send this for you to solve, okay? Is that okay?
Yes, doctor.
Yeah, so you go through the same procedure. As I said, number 1, you write the hypothesis. In this one too, we have 3 samples. So your HO mu 1 is equal to mu 2 is equal to mu 3. Then the HA will say that not all the means are the same. Once you do that, go on and find your SSB. By finding the SSB, we said that we need to understand the mean for each of the group. So the sample mean for Legon branch, Silver Star Tower branch, and the ANC branch. Then when you are done, you find the grand mean, X bar bar. That should help you solve for SSW. Then we need the degrees of freedom for numerator, okay? And that is giving us what? K minus 1. In this case, how many distinct population, or do we have 3 minus 1? Then when you are done, you find your SSW. In fact, this should also help you to find the MSB, which is SSB divided by degrees of freedom or numerator. SSW says that for each of the sample size you have there, subtract it for each group, their corresponding what? Mean, and square them. When you finish, you find degrees of freedom for within, which is denominator, n minus what? K. N, we said n is the sum of all the what? Ith elements, which is a sample for each of the independent or distinct sample that you have. In this case, they are still same. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That is what? That will give you 12. So 12 minus 3 shall give you this. When you finish, you find MSW. After you find MSW, then you go further to find the F computed, which says that MSB divided by MSW. Once you find this, go further and find the F critical. And we are saying that F critical in this case, we are using the F distribution table, which says that F alpha, degrees of freedom for denominator or between groups, degrees of freedom for, this is numerator, sorry, and this is denominator. So you have 0.05 here, you have 2, and you have what? 9. Use that one to find. Then you compare the F critical value and the F computed value. If F computed is greater than F critical, reject null hypothesis. Then you can draw your conclusion. However, as we've said, you can't generalize your findings that way. So go ahead and establish exactly where does the difference exist. And we said you can use the 2K Kramer critical range, or you can use the Fisher LSD critical range. The procedures are the same. So I want you to take your time, go through this example, then solve it. If you have any challenge, do send me your problem or the question so I can assist you in answering or finding solution to your problem. So I'll send you this question for practice. On that note, that ends our discussion for analysis of variance. Why we choose analysis of variance, we've explained, and what assumptions do you have to observe as a researcher, or if you're a business person and you want to use Anova, the assumptions must be clearly defined. Go and collect or do your questionnaire by way of collecting samples. We can use the computer to do all this, so you don't have to stress yourself. As I said, for your evaluation, I either take you through, ask you questions and how to compute each one of them, or I will simply give you this table here. Sure.
Please, sir, the table is not displaying, sir.
This table for you to analyze. Just like I said about the solver table, I can give you this guy, that guy, this, delete all this, or give you some, delete some, come here, delete everything and ask you to compute it. If it is even multiple choice question, I will still give you this table, or we will still give you this table that you can use to compute all the way to deriving the F computed and the F critical value. Then I will ask you the conclusion, okay? So that is it for analysis of variance in simple terms. Good. The next discussion is also going to look at what about if you have different data altogether, okay? But this time around, you are looking at, can you check whether there are relationships among some data that you collect? For example, is it true that the more advertising we do, the more sales comes into the business? What is the relationship between